and what are the properties of graph? Anyone? First, what is your observation in the last class? That is what I am telling. Hello? Hello?
It's a nonlinear data structure contains nodes and vertices.
Okay. What is the difference between tree and graph?
In a binary tree, there will not be cycle type of node.
Sorry?
In
There will be
binary tree,
cycles
the
in
node
graphs, sir.
Okay. Means, but cycles is
all the
mandatory in a
nodes will
graph.
be connected.
Cycles are compulsory in a
Cycles
graph.
are no, sir. It is not mandatory in graph.
Hmm. That is what I am asking. That is why. What is the difference between graph and tree?
Graph we can choose any node as start node, but in trees we can choose only root.
Yeah. Yeah. This is the very important difference. So always we can use only one node, that is a root node, as a start node in a tree. But in a graph, we can use any node as a start node. Correct.
Yes, sir.
So that is why there is a chance of cycles. If it is there is no cycle also, you can call it as a graph. But you can tell one more point also. All trees are graphs, but all graphs are not a tree. Correct.
Yes, sir.
Yeah. I don't know. Today only very less students are joined. I don't know. Okay. Now today we are going to learn sure how many ways we can represent our graph. Yeah, basically three ways we can represent the graph. But in your syllabus, you people are having only two ways. As a academics, you require only two. But even I will show you three ways of the representation of the graph. Very simple way we can represent. If you know, if you are having some knowledge in a matrices, then representation of the graph is very important. Here, before discussing the graph representation, already I given some of the important points. That is a terminology. What is a vertex? What is a edge? And types of edges: undirected edge, directed edge, weighted edge, undirected graph, directed graph, mixed graph, end vertices or end points, origin, destination, adjacent. Very important, this adjacent, incident, outgoing edge, incoming edge, degree, in degree, out degree, parallel edges or multiple edges, self loop, simple graph, path. So all these properties or maybe the terminologies, I think everyone is understood. All of you understood these terminologies? Yeah. If you know these terminologies, then today's class is very easy and easily you can understand. That is what I am asking. Understood?
Yes, sir.
Yeah. Today we are going to learn and practice even parallelly. You also practice on your notebook, please. Here we can represent the graph. How to represent the graph? Here basically we have three ways of the representation. One is adjacency matrix. Another is the adjacency list. Even here adjacency incident matrix also there. This is not there in your I think syllabus, but it is also very important for placements and other things. That's why I'm going to show these three ways: adjacency matrix, incidence matrix, adjacency list. If your adjacency matrix, adjacency list, already you know what is the meaning of adjacency. What is adjacency? What is adjacent node in a
Next to,
graph?
sir.
What is adjacent node in a graph? Already this terminology we already discussed about that. Hello. What is adjacency matrix? What is adjacency? Already we discussed about here already adjacent. Already we are discussed in the last class. What is the meaning of adjacent? So if you know that only, we can understand. Please
A node after
tell
another
me
node
fast.
in a path.
The connected node. Next connected node is called as adjacency. For example, if you want to check adjacent of any node, here that node is connected whatever the node. For example, the adjacent of A. What is the adjacent of A? Now here, adjacent of A is what? What are the adjacent nodes here?
B, C, D.
Yeah, B, C, D means the connecting nodes are called as adjacent nodes. Clear?
Yes, sir.
So based on this logic only, our representations will work. That is why I asked you. Very important. Now the coming to the first representation. Please follow, very easy. If you know the mathematics, it is very easy. The first representation is adjacency matrix. So matrix way we are going to represent with help of adjacency mechanism. You know what is the adjacency and you know already matrix. Okay, matrices representation, everyone knows, right? For mathematical matrices representations. Hello. Matrix representation.
Yes.
How to represent
Yes, sir.
matrix?
Number of rows and columns.
Rows by columns. So that is the representation of your matrix. So now this adjacency values we are going to represent in the form of matrices. That is called as adjacency matrix. Nothing is there. Very simple. So before going to that, just I'm going to tell you in this representation the graph is represented using matrix of size the total number of vertices by a total number of vertices. Means you are going to find the how many number of vertices are there in the graph. So that is the size. Okay, that is the size of the matrices. That means this graph. Sir, how many vertices are there in this graph? Can anyone tell? How many vertices are there in this graph?
7.
How many? Seven vertices. Here now we want to represent this graph in a matrix form. Your matrix size is 7 by 7. Understood? Understand? Hello? The size of the matrix is number of vertices in that particular graph. Understand? Hello? Hello? Sir, I'm not getting any voice from your side. No response. Is it audible?
Yes, sir, it's audible.
Yes, sir.
Yes, sir.
Yeah, what I'm telling is when you are going to represent a matrices, the matrices must size must be the number of the vertices by number of the vertices. So first of all, you have to calculate number of the vertices. So that is going to represent that into same number of the vertices. For example, your graph is having 7 vertices, then size of the matrices is 7 by 7. Are you clear?
Yes, sir.
Yeah. For example, if your matrix is, if your graph is having 7 vertices, the size of the matrices is 4 by 4. 4 vertices, then size of the matrix is 4 by 4. In this way, we need to calculate the size of the matrix. Clear? In this way, we need to calculate the size of the matrices. Clear? The response is required.
Yes, sir.
Then now, okay. Now the size we know the size of the matrices. Now, what values we have to fix? In this matrix, both the rows and columns must be corresponding. What is this? Already I told you. Now, you need to fill 1 or 0 for each row column value, each index value. Then how to use this value? Here, 1 represents there is an edge from row vertex to column vertex. Means there is a adjacency matrix is there from row to column. You can represent 1. If there is no any adjacency, then we can represent with 0. Clear? Clear?
Yes, sir.
Yeah. Now, for example, I will show you this with one example, then you can understand more. Okay, just sharing the thing. Now, is this visible now, everyone?
It's a visible.
Yeah. Now, this is a graph. This is a graph. Now, I want to represent in a adjacency matrices. Clear? Hello? Please, dear students, response is required. Otherwise, I will stop the class.
Yes, sir, it's clear.
Yeah, please respond. Okay. Now, tell me, what is the size of the matrices I have to represent for this graph? Hello?
That is plus 1.
Huh? Hello? What
7
is
by 7.
7? How many vertices are there here?
5.
How many?
5
Ah,
by
5 by
5
5.
only. Then what is the size of the matrices?
5 by 5.
Yeah. So please don't tell blindly. You please observe the things exactly what I am going to explain. Okay, right. It is a 5 by 5, correct? Yes or no?
Yes, sir.
Yes, sir.
The matrix representation is 5 by 5. Please follow, very easy actually. Don't confuse, that's why. Just I am representing rows and columns. A, B, C, D, and A. Right. Now tell me. Here, now very simple way you can representation. It's a two-dimensional matrices. Very simple. Okay. Now tell me. Here A to now A to A from row to column A to A. Is there any edge between A to A means adjacency from A to A? Hello. A to A row, A column. Is there any adjacency?
No, no, sir, no.
If it is no, what should we write here?
0.
0.
So, very good. Now A to B, row to column. Okay, A to B. Is there any adjacency from A to B?
Yes.
Yes. If it is yes, what is the representation?
1,
1.
sir.
1. Very good. Now next A to C. A to C.
1.
1. A to D.
1.
1.
1 again.
A to E.
0.
0. B to A.
1.
B to B,
0.
B to C,
0.
0.
B to D,
1.
1.
B to E,
1.
C to A,
1.
C to B,
0.
C to C,
0, sir.
C to D,
1.
C to E,
0, sir.
D to A, D to A,
1.
D to B,
1.
D to C,
1.
1.
D to D.
0.
0.
Observe D to D. Check the graph here. D to D. Loop is
1.
there or not?
1, sir.
1. 1.
This is self loop is there. Then is 1. D to E.
1.
1.
E to A.
0.
0.
0, sir. 0.
0, sir.
Yeah. E to B.
1.
1.
E to C. E to C.
0.
0.
E to D.
1. 1.
E to E.
0.
So this is the representation of graph with help of adjacency matrix. Clear? Very
Yes, sir.
simple. Understood everyone? Yeah, this is the way to represent. This graph we are represented in a adjacency matrices. Clear everyone? So this is very important 8 marks question. Is it clear?
Yes, sir. It's
Yes, sir.
Yeah. Here now this graph is for what? This graph is directed graph or undirected graph?
Indirected.
Undirected.
Directed or undirected?
Undirected.
Undirected, sir.
Why undirected?
No arrow symbols are given.
Yeah, there is no direction in edges. Okay, in the same way, we can represent a directed graph also in the form of matrix, adjacency matrices. Are you clear?
Yes, sir.
For that, again, same procedure is same. Here, number of vertices. How many? How many vertices are there?
5.
5.
5.
Then matrix size is 5 by 5. Correct.
5 by 5.
Yes.
A very simple one. Just you can understand what is matrices and what is graph and what is adjacency. Then you will get 8 marks from here. Now tell me, A to A. Is there any edge from A to A?
No, sir.
No.
Then what should we write here?
0.
0.
A to B,
1.
1.
1.
A to C, A to C,
1. 1.
1.
A to D.
0.
0.
0.
Yeah, very good. Because it is a
Directed graph.
it is a undirected graph. You have given 1 because it is there. But it is a directed graph. We cannot write okay A to D. Understand? Understand?
Yes, sir.
Now A to E,
0.
B to A,
0.
yeah, B to B,
0.
B to C,
0.
B to D,
1.
B to E,
1.
C to A,
0.
C to B,
0. 0.
C2C,
0,
C2D,
1,
1.
C2E,
0,
D2A,
1,
1.
D2B,
0,
D2C,
0,
D2D,
1,
D2E,
1,
E2A,
0,
E2B,
0,
E2C,
0,
E2D,
0,
E2E.
0.
Here, this is the representation of matrices, representation of adjacency matrices for the directed graph. Clear? Clear?
Yes, sir.
The thing is that both the representation are in the same way. Only the thing is here the directions are not there. Means it is a undirected graph. If the directions are there, then you need to follow the directions. That is the difference. Clear this adjacency matrices representation is clear, everyone?
Yes, sir.
Yes, sir. Yes, sir.
Yes, sir.
Now coming to the incidence matrix. Here it is also looking like adjacency matrices, but the incidence matrices is somewhat different. It is worked for only the directed graph. It is not going to work for undirected graph. Are you clear? Hello?
Yes, sir.
Yeah. Now here in this incident matrix, the size of the matrices we must be cover the total number of vertices by total number of edges. So the size of the matrix must be the total number of vertices by total number of edges. So how many number of vertices are there here? Tell me. How many vertices are there in this graph?
5.
5. Yeah. How many number of edges are there here? 8. Now the size of the matrix must be 5 by 8. Understand?
Yes, sir.
If okay, the size of the matrix must be 5 by 8. Here now how to represent this adjacency? The representation of adjacency is very easy. Okay, we are going to represent same row to column wise. For that, we have to use 0, 1, minus 1. 0 means the row edge is not connected to column vertex. That row vertex is means that vertex A is not connecting to that column vertex. That is, we are going to represent with 0. There is no edge for that node is called as we are going to represent with 0. Here 1 represents that the row edge is connected to the outgoing edge. Okay, if there is an outgoing edge, you need to write 1. If it is an incoming edge, you need to write minus 1. If there is no edge, you need to write 0. Simple. If there is an edge, you need to check it is outgoing or incoming. If it is outgoing, you need to write 1. If it is incoming, you need to write minus 1. If there is no edge, you need to write 0. Clear? Clear?
Yes, sir.
That's why it is only for, this is only for directed graph, please. Okay, very simple. Okay, now I will show you. Here, before preparing the matrix representation of this incidence matrix, incidence means edges. So that's why you need to write, you need to specify some names of that particular edges like this. So that is, you need to define. You can take anyone. E1 is this, or E1 is this, or E1 is this, whatever it is. Finally, you must be label the edges. Then only we can understand very easily. Okay. So based on this labeling, now graph this graph I am going to represent with incidence matrix here. Now the all columns must be, all rows must be no nodes. Means what is this? What are those? Tell me anyone? Because already I told you the incidence matrix size is number of nodes by number of edges or number of vertices by number of edges. Clear? The size of the matrix must be number of vertices by number of edges. Clear?
Yes, sir.
Yeah. Now,
Yes, sir.
how many nodes are there in this matrix? How many nodes are there? 5. What are those? A, B, C, B, C. Correct? Yes or no?
Yes, sir.
Yes, sir.
Sir, how many edges are there?
8.
8.
8.
How many edges are there?
8.
8.
8, sir.
Hello?
8, sir.
7, sir.
8 edges. What are those?
8. 8, sir.
E1, E2, E3, E4. What are those?
E5.
E5,
E7.
E7.
E6,
E7.
E7,
E8.
E8. Now the size of the matrices is 5 by 8. Understand? Understand?
Yes, sir.
Understand this? Yeah. Now we need to find the edges incidence now. A to E1. Here, A to E1. A to E1 is there. A to E1 is there. No?
Yes.
In this graph, A to E1 is there or not? Yes. If it is edge, it is outgoing edge or incoming edge.
Outgoing.
Outgoing. Outgoing 8.
If it is outgoing edge, we need to represent with. If it is
Minus
outgoing
1.
edge, we need to
One.
represent with. For
One.
outgoing edge, -1. 1
For
only.
incoming,
Plus
minus
1.
1.
Now A to E2. A to E2. For A, E2 is there.
Yes, sir.
If it is there, then you need to check it is incoming or outgoing.
Outgoing, sir.
Outgoing, sir.
I mean running fast. Outgoing. If it is outgoing, what should we write here?
1.
What should we write? Outgoing. 1. Now A to
1,
E3. A to E3 is there.
Yes, sir.
From A,
Yes, sir.
E3 is there. But it is outgoing or incoming?
Incoming, sir.
Incoming.
Incoming.
Incoming means what should we write?
-1.
What should we write? -1.
-1.
Now A to E4. A to E4. Or A to E4 is there?
No, sir.
No, sir.
No, sir.
If it is no, what should we write?
0.
0.
0.
0. Very good. A to E5?
No, sir.
A
No,
to
sir.
E5. What should we write?
Zero.
Fast.
0, sir.
0. A to E6? Now
Zero.
tell directly. A
0.
to E6?
0, sir.
A to E7?
0.
0.
0, sir.
A to E8? A to E8?
0.
0, sir.
A to 0. Very good. Nice. Now B to E1? B to E1?
Minus 1.
-1, sir.
-1. Very good. B to E2?
0, sir.
B E2?
0.
0. Very good. B E3?
0, sir.
B E3? 0. Right. B E4?
1, sir.
1, sir.
1, sir.
1. Very good. B E5?
0, sir.
0,
0,
sir.
sir.
0. B E, yeah, right. B E6?
1, 1, sir.
1.
Good. B E7?
0, sir.
B E8?
0.
1, sir.
Very good. Right. B E8?
Oh, sorry, 0.
B8.
0, sir.
8 is here.
0, sir.
CE2.
0, sir.
0, sir.
CE2.
1, sir.
Please
1, sir.
observe the graph.
1.
How it is 1.
-1, sir.
-2.
Incoming edge is there. Don't tell blindly. Verify the graph, please. Okay. The E2 is incoming edge to C. That's why you need to write -1. Don't confuse. Is it clear? No?
Yes, sir.
If you're having doubt, ask me. Don't worry. Even if it is wrong also, you can. Then I will correct it. C2 E3.
0.
C2 E3. C2 E4. Hello? Now no one is responding. C2 E4.
0.
Time is running here. One more model is there.
0, sir.
C2 E5.
1.
1.
C2 E5.
1.
C2 E5.
1.
Outgoing
sir.
edge. Then here E5 is there.
1, sir.
C2 E6.
0.
C2 E6.
0.
0, sir.
0.
C2 E7.
0.
0. 0.
Good, right answer. D2 E1. D2 E2.
0, sir.
D2 E2. 0, very good. D2 E3.
1, sir.
1, sir.
D2 E3.
1.
1.
Very good, 1. D2 E4. D2 E4.
-1.
Very
-1, sir.
good. Because incoming edge is there. Yeah. D2 E5.
-1.
D2 E5. Very good. Incoming edge is there.
-1, sir.
D2 E6. D2 E6.
0. 0, sir.
Yeah, good. Yeah, good. D2 E7.
1.
1.
D2 E7. 1, very good.
1, sir.
D2 E8.
1, sir.
-1.
1, very
1.
good. Yeah, 1. E2 E1. D2 E1. E2 E1.
0, sir.
0,
0,
sir.
sir.
E2 E2. E2
0.
E2.
0.
0, sir.
E2 E3.
0, sir.
E2 E3.
0, sir.
E2 E4.
0, sir.
E2 E5.
0.
E2
-1.
E6.
-1, sir.
-1, sir.
E2 E6. -1.
-1.
E2 E7. E2 E7.
-1.
Yeah,
0.
good. E2 E8. E2 E8.
0, sir.
0. Now understood this? Yeah, very good. Incidence matrix representation is understood,
Yes, sir.
everyone?
Yes, sir.
Yes, sir.
Yeah, very good. Now the last one is adjacency list. So adjacency list. Adjacency matrices, you know. Here we are going to represent in the matrix way. Here with help of matrices, with help of adjacency node. Here for directed graph and undirected graph. And incidence matrices is based on the incidences. Means that edge is connected to the particular node or not. So that is the incidence matrix. So the last one is adjacency list. Here, this adjacency list is based on the linked list mechanism and array mechanism. Two ways we can use, but this adjacency list and incidence matrix is only for directed graph. Are you clear?
Yes, sir.
Yes, sir.
Incidence matrices and adjacency list only possible for directed graph. But adjacency matrices is for both. Remember this point, very important point. Adjacency list and incidence matrices only for directed graph. But adjacency matrices is for both directed or undirected. Clear that point. You remember that point. Clear? Clear? Hello?
Yes, sir.
Yes, sir.
Hello? Yeah. Now we are going to understand adjacency list. If you know linked list mechanism, then very easily you can understand every node is having the node value and connecting to its next node. That is a single linked list mechanism. Now adjacency list, very simple. We can represent very easily. Just I will show you. Here now, generally, here how many nodes are there here? How many
Five,
vertices
sir.
are there? 5.
Five
Here
nodes.
now you must be represent those vertices in a linked list fashion, in a vertical way. The first one is any order you can take it. I am taking order A, B, C, D. Here this is the linked list mechanism I have taken. I have connected. Okay. Then I am going to check the adjacency nodes and which how they are going to connect. So from A, what are the outgoing edges? Connected nodes. Tell me what are the outgoing edges? That is what we have to connect from A.
B, sir.
BC.
From A, B is there. Very good.
C.
Now from A, is there any other node?
C,
C,
sir.
In
sir.
adjacency? C also there.
C also.
Then C is connected. From A is other than this B and C, is there any other node?
No, sir.
No,
From
sir.
A, no. If it is no, then it is a null. Clear? Clear?
Yes, sir.
Yes, sir.
Yeah. Yeah. From B, what are the outgoing adjacent nodes? Okay, we have to check.
D
From
and
B,
E.
what are those?
D and
D.
E.
So D is there.
E
Then
also,
from
sir.
B, E also there. Correct?
Yes, sir.
Is there any other than this? No, right? Only two, right? Then
Yes,
null.
sir.
Fine. Next from C. Tell me from C. What are the outgoing edges? Means adjacent nodes.
D, sir.
Only D. Is there any other node? No. Correct?
No, sir.
Then null. From D. Tell me.
E.
What are the adjacent nodes from D?
E, sir.
A and E.
From D, what are
A and
A
E.
and E.
the A and E?
E.
And one more node also there. Check.
D, sir.
D, sir.
D, sir.
D also there. Very good. So all these are adjacent nodes. Then null. Are you following? Are you following?
Yes, sir.
Now from E, tell me what are the adjacent nodes?
Null, sir.
Null, sir.
No node is there for adjacent of this node. That's why it is pointing to null. Understand? This is adjacency list with help of linked list representation. Linked list representation for adjacency list. Clear? Hello?
Yes, sir.
Yes,
Clear.
sir.
Okay? This help of single linked list, we represented adjacency list this. Clear?
Yes, sir.
Yeah. Now with help of array, we can represent same same graph you can consider, okay, directory graph, then you can represent with help of array also. For adjacency list, this is for adjacency list. We can represent with linked list as well as we can represent with array also. Are you clear? Yeah, sorry for the inconvenience, just power gone and came. Now is it audible?
Yes, sir.
Yes,
Sir,
sir.
audible.
Yeah. Okay. Now what we are discussing? Now adjacency list representation with help of array, correct?
Yes, sir.
Yeah. Now, yes, how many number of nodes are there? You have to represent array with the vertical format. What are the nodes? What are the vertices? Tell me.
A, B,
Zero
C,
indexing
D,
A,
E.
B for one indexing, C for two indexing, are you clear? Are you clear this?
Yes, sir.
Hello? Yeah. Now, from A, what are the adjacent nodes? Tell me quickly. Time is running.
B
What are
and
the
C,
adjacent
sir.
nodes for A? This is the array
B and
representation.
C.
B and C. Zero indexing, one indexing. Correct. Now for B, what are the adjacent nodes from B?
D and E.
D and E.
B and E. B and E. From C,
D,
D,
sir, only.
D.
D,
only D. Okay. From D,
D, E,
A,
A,
D, A, D, E.
A, D, E.
A, D, E. From E,
Null, sir.
Null.
thing is there. Okay, not connected. Here, this is the representation of the given directly graph by adjacency list with help of linked list and with help of array. Now clear, everyone is clear?
Yes, sir.
yes,
The
sir.
representation of graphs is clear, everyone?
Yes, sir.
Yes, sir.
Please practice it and work on that. If anything is there, we will discuss in the next class. Okay? Come with some good preparation.